Hello, back again to this course, Golang Microservices full course. Yeah. In this video, we are going to talk about the splitting transaction service. Because in the previous video we have already implemented the ledger service. So now we want to try implement the transaction service, and then to make sure both transactions and the ledger is working properly. So the concept is we still want the dedicated MySQL database and the table as well, which is the transactions table to store the transaction detail and perform idempotency key validation. And then we also want to create the gRPC coordination, of course, which is receiving a transfer request service should contact the user service, wallet service, and ledger service. And I think we can go right now. I wanted to try here. Okay, check out master and git pull origin master, and then I want to try clear make directory insert transaction services config database and transaction, and I want to cd the transaction service. I want to go mod init, right? Init github.com should be pass your code, your username, go wallet, your repo, and then microservices is the directory inside the transaction service, and this is for the service. I think yep, this one should be okay. I wanted to try to check go mod. We have already have go mod here, and I think go work use cd go work use transaction service dot slash transaction service. Let me check here. We have already transaction service inside the co-work, so this will be fine. Then we want to create the helper, the configuration, the transaction repository, and so on. So here I was already try. Before do that, don't forget to copy all the transactions, to copy the transaction service to the Docker file of our service. Yeah, each. This one is the first is the API gateway, and then the out service here, and then for the ledger service here. Yeah, this should be working. Of course, this should be need to add, and then after that user service, and don't forget to wallet service as well. Yeah, because we have already implemented all of the service. I think this is the last service if I'm not mistaken. So yep, close to the right. Then I wanted to try to go to the env, which is here, the db name database env should be wallet transaction, and our env wallet transaction, and then the Docker compose. Yeah, I think we should create as well, which is here in under the ledger service. Let me check the ledger service here. Ledger service, is it the first? Yeah, this one. And then we copy the transaction service, and the transaction service also we copy here. Should be under the ledger. Okay, can under here, you can put anywhere lah. And then I think depends on is also depend on. Yeah, first is depends on. Oh yeah, this one already done, the depends on. So API gateway will start if all of the service that we have is started. Yep, I think should be done. Go work also have. So we continue to the transaction service, which is I want to go to the transaction service, and what I should create first is main.go, clear. Wanted to close to the right. I wanted to close this to make it more readable, so we open only this one. So I wanted to touch cmd main.go. This is for creating file, and we have already filed this one. But I think this is will have an error, of course. So here I will copy. So let me check what is the error. We doesn't have the transaction service and the transaction handler, repository, and then service. When we see here, I already logger first, load config, connect Redis, connect with retriever the MySQL, and then connect to the user gRPC, and then user client, and then connect to the wallet gRPC, and then connect to this ledger service gRPC, and here is initialize layer and logger, recovery, error handler as usual. And then if we see in the monolith, we do transaction is only 3, only 3. So protected transaction is only 3, transfer, top up, and history. So we also copy this one, should be. So the 3 API will be here, and then I wanted to create the other, which is the share handler.go. So touch internal, and then transaction handler, touch handler.go. If no, then should make directory first. I wanted to make the dir internal here, empty -p, yep, and then touch. Then we have already here on the section and handler. Wanted to copy as well. This is for the API and the go, and then the generation of the of the API, REST API Swagger. I forgot the name. So first is transfer, and then get history, and then top up. Okay, should be done, should be good. Then we do the pagination model. So here and make directory, I think handler, and then model, repository, and service model, repository, and service. Okay, yep, we have already created all, and I want to copy the model pagination. This is for the history. Okay, so touch and internal transaction model pagination dot go. Here I copy. Okay, and then model for the transaction. Okay, tx.go here. Okay, GitHub, thing, and then package repository is for the repository.go. We copy here, touch internal transaction repository and repository.go, and we copy here. This is also create, get item potency key, get history, update status, and then after that for the service For the service here, we touch internal transaction service.go. Here I think we have mark field. Wait, we have transfer, get history, and top up, and then we have here is mark field, yeah, I think, and then we create the docker file, touch docker file here. We copy, yeah, should be the same as the other service, yeah. And I think go mod and go sum is just go mod tidy. Go mod here, go mod tidy. Go mod, I think I also need to replace, yeah, ledger service, user service. This one I will copy. I think this one will be error later. Go wallet microservices. Wait, no error, yeah. I think I will try to check. Okay, I think this one should be fine. What if I try to here like this? Go mod tidy, yeah, adding this one automatically, so this one should be good. Okay, but we don't need to create the gRPC right here, yeah, I think. Let me check. gRPC is created in where, because I think right we should have updates, record the data that have top up or have history or transfer. And ledger client, this is record ledger entries and should be inside the proto. So already done with the client. Okay, debit and string, because this is different from the monolith for the communication, but the important thing like the validation, the get ID user, get valid user is pretty the same. And then I think okay, but let me check the transaction service is inside the, wait, I hasn't started this yet, so I want to stop. I want to docker compose up dash d up build up dash d build, sorry, I forgot. I will try to check the history. I forgot how to build. Yeah. Okay, cd, and then here transaction port is not set a blank string. So in the docker compose microservice docker compose transactions port, in the env we transaction port. Okay, we should create transaction port here should be, wait, 8086. I think if I wanted to see here, 8086, yeah, new service in 8086. Okay, then for the payment service, for the service gateway should be transaction service 8086 payment service. I don't need payment service because we haven't configured this yet, but I think okay, we can remove transaction port 8086. Okay, I will try again docker compose, and I will pause the video until this was. I think I got an error. I will try to check. Well, do that. I think I need to create a migration file because we have the date, because we need to create the table. Yeah, I think first I think I need to create the file. Just me create txt sql -dir db migrations SQL. I think I need to add the transaction service here, service, because I'm on the directory microservice, and this one should be add transaction table. Okay, I got this one inside here in the database, transaction service. Wait, I think I have already, but why I cannot get the transaction service db? Oh yeah, db here, sorry. So db here, transaction, and I drop table if exists. I just copy from here to here, transaction. Okay, I think I will to check. So how to fix it? This is because memory inside docker container limit. Yeah, I think I got the limit here. Wait, increase the docker memory. Okay, I think I need to increase first resources here. I think 3. Let me check if 3 is can or not. I hope can, because it's taking too much memory RAM, and my computer is only 8 GB. I think I will try first, yeah, this one, and I will try to pause the video first. Okay, so I think I will try the other thing to make our project works. Yeah, I try to create a make file. This is first is I get the processor architecture, maybe ARM64 or x86, and then determine the target compilation. So this will suitable for the Linux in Docker. If x68, then AMD64, and then if ARM64, then we use ARM, and then the service is API gateway, host service, user service, wallet service, register service, and transaction service. And I mark the targets as using the phony, which is all build Linux, build native, clean help. This is a make build Linux, make all, make with, yeah, something like that. And then the default target, if I run make command, so will only this one, all is help. So target commands, I think I will look through each service that has been registered and create the bin folder if not exists, and then run compilation, and then I reduce the binary size, which we reduce the binary size, This is the build Linux command, and then build native is compile all service is natively. If we want to work without Docker, but if we want to work with Docker, we can create a bit Linux, and clean is remove all the bin folder inside the workspace, and this is to help displaying the usage quite lah. This is because my RAM is not enough if we directly go build Docker Compose, yeah. So I think like this. First is I make build Linux here, and we'll have a directory later. I will wait a second. We in here to try. No in here, yeah. This is API gateway building. We have a bin here, and then out service and wall service, ledger service, and all binaries build is successful. So after that I will go to Docker file, and then this is copy binary, right, from the builder stage. This is built inside the Docker, but we built inside our computer. So I just copy here. I'll find apk no catch add user app user work directory app, and then this one should be I comment here, and I do here user app user expose 8080, yeah. Then I will do that as well for the out surface. I copy here, yeah, and then for the user, so out service and user service. Now user service, where is my user service? Ledger service first. We have ledger service, and I think just something like this, ledger, right? And then after the transaction, my command transaction, and for the user I comment this as well, and user service Linux service would be fine. We have a wallet service as well. I comment this one. Yeah, this is should be good, but I think I will try to Docker Compose up. Yeah, this one is starting. Okay, good. Something like this to make our data, yeah. Yeah, we can do with build manually lah, for so not make our container very high usage RAM. And I think I have a wallet transaction, but I don't have anything there. That's why I want to migrate. Okay, migrate is same, migrate path, transaction should be, and db migrations, and I copy database, and this one should be wallet transaction. Okay, with s or not, let me see. No, we don't have s in that. And then when we refresh, we get a transaction table. Okay, and what I want to do right now, I think I want to try with users. I have a free run, and I think I will register the firm, and I run here. I should be fine. And then I think What I need again is folder, which is transaction service. Here first I want to top up, so top up transfer, and what was that, the last one? I think I will check first. The last one what we have is transaction service inside the cmd file. The history, okay, the history get. So here I think, here copy, and then I just paste here, paste. Okay, should be delete this, the copy name. I don't want to see the copy name here. Okay, and then the transaction history. Okay, and then top up as yeah, I think I will log in first with the freelance. For now I want to transfer from freelance to the firm user. So I go to the variable token, I top up here. This one should be working, and if we try to check the ledger mutation, yeah, credit, and then get the reconcile, and yes, true, it's consistent, is true. And then if we try to transfer to where, to firm, test transfer 001, this is item potency key, yeah. And then we got the transfer and transaction history. I think I get the first is test top up and then test transfer. And if we check wallet, should be 90 balance and currency IDR, and then version is 3, because every time first is version 1 and then version 2 is top up, version 3 is transferred to firm. And then if we try to check the ledger mutation, I think we have the data, which is debit, and then which is the credit. Should be fine, like reconcile, yeah, true and true. Yeah, should be fine. This transaction service should be nice, to working fine. So I wanted to check out again, to here get check out dash b feature 028 yeah, I think 028 transaction service. Okay, I wanted to wait, I think I don't want to adding something like the bin, so bin here like this. So yeah, the bin one should be not included. What is this? No, still no. Yeah, this one should be correct. And I wanted to generate, and I want to commit and publish the branch, and then I will make some pull rack here, pull request, click pull request. And the last pull request I wanted to close. I'm sorry, this is one is my temporary branch, temporary pull rack, and I have already here. So what's wrong with the last time? I think we need to check the other things, which is I will close our first and terminate. We have something like in-house service in CMD, and in the user service cmd.go, I think we have mistakenly put the out Google to the main.go, yeah, to the user service. So we will do this move to the main.go, and I will not test this yet because I was revoke my API key. And if you want to try, you can try. I just want to show you how to do that, and I don't think I will test again because last time we have already implemented in the monolith. If anything happen, error or something, it's yours. I leave it to you. You can fix it by yourself, right? I think you will I think you will know, you will success for that. Yeah, this should be my proto last time. Yeah, I think I have to commit master, which is implement transaction service, and this one. Okay, so first is I think I remove API gateway, right, inside here API gateway. When I forward to our house is no need, so I delete. Yeah, I delete login, refresh, logout, and our user for this is in house / Google user proxy / Google user proxy is not good, so I copy here and I remove this one. 60, this one I remove, and I think this one should be fine. So I want to create the proto file, which is proto file is user proto. I add new here inside the proto, which is create user request. Yeah, no need lah, later. So I will go to the out service first to make this. Doing out service is in the main.go IPB wallet, and then user connection to the new client gRPC user address here. I think I will copy here to change as the user cons, then connection change to user con, and this one also user connection. I add the wallet connection, which is here and then wait, I only copy from here. How to so hard to copy. I'm not sure why this is so hard to copy. I copy here and then cannot. Yeah, I should copy like this. So hard to copy here. I'm sorry. Let me check. Copy and then here wallet connection, and I add wallet connection inside the out services. Yeah, wallet client connection. Then we have an error because out service is not accepting out connection, right? So here I add the Google login first API, and we don't have out handle Google login as well, and I want to replace here in the Go mod inside our service. Here Go mod, I to add the replace to the wallet service. We have an error, of course, but I think we add in the handler.go first. So here this is so hard to copy. I think I need to like this and copy inside the out handler here in the bottom, I add these two, get Google login and then Google callback. And then after that we add out service, of course. In the out service here, in the out service we add here, and we should add the function wait, the out service also, here should be wallet client pb wallet, and then copy the pb wallet here to make it not error, and here we add like this one, the wallet client inside here, and then here we copy this one. Wallet client, and then okay, I need another, which is Google OAuth struct, and the service I will copy until bottom here. Wait, so cannot copy, this one is weird, but no problem. Okay, we have already tried. The user client create user is not working yet because we don't have the user proto. So proto, we need to create the create user response. This one error is from the user proto. Think what I have an error here, the database OAuth is not in your command file letter. I think in the proto, inside the proto, I create the RPC inside user.proto. Here is user service. I add new function, and I add new request, user request here should be good. Then I do protoc again, which is protoc to generate. Okay, so proto, this is for the user proto, user and user proto, and when we get the github.com, I will copy this one into the user service inside this proto. So I delete this one first, and I where user service, and I paste here, and then should be fine. And I delete the GitHub folder, and I try to check inside the out service. Do we have any error? Any error again here? No, we don't have any error. The error is inside this one. So what happened is this, because I need to go mod tidy inside the out service, go mod tidy, and let me check. No error again, no error, so we don't have any error here. And after that, out service already, out service, let me check out service. Or repo don't have handler, only handler and out service, should be fine. Then we do GitHub, this one is okay, user proto is okay already. Yeah, we delete inside the user service. We don't need the API callback again, so we delete, which is here. And then after that we delete inside the gRPC server. We add, not delete. This inside the gRPC server is function for create user. I will add this one, create user if login as a Google, login with Google. Here I will check in gRPC internal inside user service, gRPC internal user service. Do we have user service gRPC here? User service internal gRPC inside here. 61, I think this one model and UUID should be automatically import. Yeah, correct. And then in the handler we remove the Google login and the Google callback. Yeah, should be fine. And the aus.go model I delete model for the out.go. So inside model out.go we have already here. And service is removing the Google user login. In the service, user service, we remove the Google login. Okay, this one should be fine. Good. 41 and 42, and we Google user info inside under here Google user info, handle Google callback, this one, and good Google login, get all out, and until here we delete. So yeah, I think should be done. And the proto, user proto, and user PB is proto user proto. What is this one? User PB. I think no. We don't need this one. Lotif user gRPC PB file proto. Okay, I think this should be fine. Let me check by what is this one. Go mod ID is inside the user service, right? User service, go mod ID, clear, should be fine. And then cd first, and I try make file again, make build Linux. And docker compose build again, and I want to try to run register first, start. I want to try is this working fine. I afraid that we are breaking, so I wanted to check. So user and Go wallet user is fine. Go wallet I should have, yeah, this one should be who. Okay, enter. Oh wait, the ID, no, I did this, but user ID this 3B4B09, 3B4B09. Yeah, stuck here. Okay, I think this should be fine. So I will try to test this behind the screen, and if you have countered something, just comment in the YouTube comment section, and see you in the next video. Thank you. Hey, sorry, cannot end this video just like this, because you know that we have code the thing here which is transaction service, but we are not understand what we are doing, right? So basically, I think I want to share to you about this Saga pattern, which is we have already implement. So the distributed transaction is, I think the transaction service, if you see, we have done in monolith, which is when we do the transaction transfer, yeah. For example is transfer. When we see service transfer, what we do is first we are checking the idempotency key. If double hit, no double hit API, something like that, we have already covered. And we are transaction DB is starting here with the begin TX and then TX rollback, and then after that, if anything good, if any of the data that connecting to DB is no error, even one, we will commit the DB transaction, so the DB will not will save we will save the transaction to DB. But this is only works if we have only one database. But how about in the microservices one? Actually, we have a lot of database, right? Which is wallet service using wallet database, ledger using ledger database, and then transaction using transaction database. So after splitting the monolith to microservice, the table is distribute across the Spirit database. So the begin, the commit, and rollback is not working here because it's not one database, but it's maybe can be 3, maybe can be 4, and etc. So for now we have wallets database A, and then ledger service database B, and then transaction with database C. So we know that since two-phase commit is slow and blocks database resource, we use Saga pattern. Saga pattern is working. What is Saga pattern, right? We will try to search first what is Saga pattern is. So architectural design pattern used to manage distributed transaction across microservices. Instead of locking database global and breaks a large transaction into series of smaller independent local transaction, and if any step fails, the Saga executes compensating transaction. I think what we are doing right now is, wait, I will try with Indonesian first so I'm sure what I talk here. So here is this pattern is separate the transaction, which complex transaction into smaller pieces transaction in local service A, service B, and service C, etc. So if one of them is fail, this pattern will triggering the compensating transaction to cancel the changes in the other service. So we have two Saga pattern, which is choreography and then orchestration. For the choreography, every service will do by themselves and communication each other with a publish and listen event, and this is for smaller workflow, yeah. But for orchestration, we have one service that have been orchestrator, and he is the command, yeah, the central command. So this orchestrator will directly give a command to the another service and watching them working with the command from the start transaction until the end. So the rollback will have work on the orchestrator. So here is the transaction service acts as a orchestrator, which is the coordinator that execute local transaction across downstream services. And we are using synchronous gRPC call, right? So first, imagine the client pause the transaction transfer to the orchestrator, and they will checking the idempotency. If we see here inside the microservice transaction service, I want to check, which is here in transfer, and we see in the service transfer. Okay, we search here. First is get idempotency key, which is checking the idempotency. This is good as this, and then create transaction with status pending. So create transaction with the status pending means that we are not directly give the user success or fail, but pending. And what is pending mean, right? Pending mean we can success this transaction or fail this transaction after checking the things in another service, like this. So gRPC calling update wallet's balance to the wallet service. If we see update wallet balance is in here. This is the Saga debit sender, and in here we call the wallet update wallet balance inside the gRPC, right? And then we have a function which is marks fail. This mark fail is we will update the status of transaction to be fail. So why we do this? This is because if we have a fail updated inside the gRPC. So if error is not nil, we mark fail. This is for the debit first, which is the sender negative amount or reduce balance, and then if you see here, we waiting until the wallet service responding success. So we can just return to the user that our transaction is pending, but for now we waiting for all. But in the real case, we will just give the response as a pending, and then we give call back to update the transaction success or fail. But now we are not using the callback yet, and then here we waiting the update wallet balance is success, and then after that we do again update wallet balance for the credit, because we have two, which is updated balance for the credit receiver and then for the debit sender. So here, if imagine if one of them is fail, like I want to transfer to you, my data was deducted, right? My data was deducted my balance from 100 to, and I transfer 10 to you, my balance will be 90. And imagine if when update your balance, your wallet is pending, or if fail, what happened to me? Myself will still deducted because this is different database, and your wallet balance don't have any changes because updating plus 10 to your balance is fail. So this is the Saga pattern. We need to do mark fail and then later we will check audit maybe and give back my money or compensation or compensating. So the system will give me my money back because my transaction to you, my transfer to you is failed. And this is the things. So this is the Saga is not blocking but checking, yeah, checking as a orchestrator, which is this transaction service, and he is giving a command to the other service, and then we should later we should compensate back, like maybe give my money back because I cannot transfer to you, and etc. Yeah, but for now we only do this. So maybe in the future we will cover how to transfer back or something, and this is very important, yeah, for me to share to you. Yeah, and then I think the other is, let me check. So flow breakdown in code, yeah, idempotency check, and then state initialization, transaction status will be pending, and then debit sender with negative amount because reducing the money, and then for the credit receiver if positive because plus the money, and then ledger also need to save, and then commit state. Ledger, if we have a credit and debit should be double, yeah. Ledger, if we already implement in the monolith, we have two, which is credit and debit. But if one of them is failed, so it should be only one, maybe debit lah, maybe debit that works, and then credit that fail. So only one ledger in here, and then later system will give money back to the sender and also adding the ledger. So we have the audit things like later, then the audit is not breaking. And then commit state is only for the response success. If we see here, mark failed is only here until the error in here, and then when mark transaction is success, we update the transaction status to be success, not to be pending, right? So in the real case, after this transaction pending, we can just return the API response, so the user will not waiting too long. This is neat because if we not doing this, the user will be waiting. But for now we are not covering the callback yet, so I just waiting until this all is done. And in the next video I think we will cover lah. So I think that's all for now, and see you in the next video, yeah. For yeah, thank you.